All right, so good morning. So this is a session about filtering and scaling in Eiffel, which will focus on various aspects of like deploying Eiffel in an organization, performance-wise, what kind of deployment architecture you might want to have. Quite a bit of talking about RabbitMQ, which again you don't have to use unless you don't want to, but it's what most of the existing practitioners use. I don't, it's until lunch, 12:30, so 90 minutes. I don't think we have material for 90 minutes. So we do encourage a lot of questions. And I think that's it. Let's look at the agenda. So first of all, we're going to have some general talk about message brokers and some comparisons between Kafka and RabbitMQ. Then a short few slides about routing keys in RabbitMQ, just to make sure it's clear. It appears to be unclear for some people. The notes on scaling and Ericsson will talk about their setup of different components and the architecture of their deployment basically, and then I'll do the same thing for Axis. And at the end, I'm going to talk about some useful patterns when you implement services that processes events. Some things we've learned over the past few years. So I'll leave it to Mattias.
So let's start with message brokers then. Recap. What is a message broker? You probably remember that is the entity that takes the messages from the producer to the consumer. The reason that we're actually talking about message brokers is that depending on what type of message broker you choose, you're probably going to have a little different setups. We're talking about RabbitMQ, and this is mainly due to tradition. It was there when we started. Kafka came on later on, but when we started, it was RabbitMQ. So the first question I might ask you, do we have a lock-in into RabbitMQ? Is it of both yes or no? On the no side, and the Eiffel protocol as such doesn't actually stipulate how to transfer the events. So you can basically use a whole big if you want to. I don't think you would, but you could. We also have a PR to show how to use Eiffel events on top of cloud events. And when you have cloud events, then you can actually use a lot of different transfers. On the yes side in the lock-in, we do have a specific protocol, and that one actually talks about the RabbitMQ and describes a little bit more details on it. We also have several of the repositories in the community sites to use RabbitMQ. So therefore, we have some lock-in. When we talk about RabbitMQ and also alternatives, it's good to think of like what is it actually doing. So if you're thinking what about speed, so this is taken from the latest RabbitMQ. They are measuring how much throughput you can put through RabbitMQ. They're choosing two different queues, the stream queues and join cores. And there we can see it's about like 70,000 to 100,000 messages per second. And this is on 8-core, 30 GB of RAM, computer-based laptop. So then the question is, are you actually going to be pushing that many events through CSA system? And this is good to reflect on why you're choosing one of the other ones. So it's not like, okay, we need a lot of performance, but you may not need it. There are alternatives. We've got Kafka, probably the biggest, most known ones. There are others. Both of them will actually enable high-speed transmission, whereas Kafka outperforms RabbitMQ in like pure raw message performance. There you can basically send, say, like a million events per second. And this is more like because of their multi-disk setup. You can, but it's also RabbitMQ, but then it requires multiple workers. And you've got the downside that if you have congested queues, RabbitMQ might not work that well. There are some pros to RabbitMQ, so if you word it. It supports the more complex routing schema. So thinking back and looking at what we have in Nancy Ericsson, I suppose we'd probably go RabbitMQ because we use a lot of very complex routing. And as I understood it, it's better support around MQ. It does have some better legacy and support protocols. I don't know if you're using like the on spot, but I think you can support those. It's also got a better widely available formal language support, probably because it's been out there longer, so that no language have that. There are a couple of conditions, so be aware. And they have their own law to say that a happy rabbit is an empty rabbit. And this is the RabbitMQ is built for like throughput, so transmission. So if you're building up big queues and so on here, Rabbit will probably not be too happy. There are a couple of gotchas also. And if you opening and closing connections into RabbitMQ, you will suffer from performance, so it's good to know about that one. And as I said, if the queues are too large or too long, you probably will have some sucker. Also note that there are older versions of RabbitMQ and also Airline that will give you lesser performance. The reason I talk about Airline is RabbitMQ is built on top of Airline. So if you're using old ones, then you have performance. So upgrading Airline and RabbitMQ can actually give you better performance. And the kind of like idea around here is that if you got 10 queues with 1,000 messages, I'd probably be happier than if you have 1,000 queues with 10 messages. So it's good to know about that. Any questions so far? So routing case wins.
Almost tore off the cable there. Good. So, routing keys. As you may know, routing keys is the way where you choose in RabbitMQ how to route incoming messages. So it's basically a property attached to the message when it's sent in a dot separated notation. And the queues would then have their binding keys. So a queue can be connected to multiple exchanges, where exchanges are the one here, Eiffel accounting and audits. So messages are sent to exchanges, and depending on the binding keys connected to the connection between the exchanges and the queues, the messages will be routed accordingly. So in our example here, we have a routing key of the incoming message of food.bar. The first couple of queues will get that message, the last one don't. And the reason is the binding key for those queues. Binding keys can contain a couple of different wildcards. So in the first binding key, foo.star. Star is a wildcard that matches anything between the dots. So anything foo.bar, foo.something, foo.whatever, that's fine. However, if we get foo.bar dot something, it wouldn't match. Did I break it? Hello, it's back. Okay. Okay. The second available wildcard is the pound sign in the second example, and it just matches anything. It could be in this example just a pound sign; it'll just match anything, or you can have it, you know, anywhere inside the binding key. We'll see examples of that later on. But the final example, without any wildcard, foo.bars, clearly does not match foo.bar, so you won't get that message. And this is, of course, very powerful in terms of avoiding messages ending up in your queues at all. And you won't have to process them. The queues won't go long, and yeah, it has many positive effects. And this, up until 2 years ago, this wasn't standardized entirely. Well, it was standardized with some tools at least, but now there's a more official standard. So this is what it looks like for in the CPM standard for Eiffel, an example of a routing key. So the first component is just a fixed prefix Eiffel, just constant. So theoretically, if you would send different kinds of messages on the same exchange as your Eiffel messages, you could use this, the first component of the routing key to distinguish between them. I wouldn't recommend sending different messages on the bus than Eiffel, but if you want, you can do it. The second token is what's called a family. We didn't define exactly what the families are in the standard because, it's hard to define or categorize events in a really meaningful way for everyone. You could say that the artifact events go in one family, but other people may have other opinions. So we're leaving it there if you want to use it in your organization, but it's not part of the standard. Token number 3 is just the name of the event type. Very simple. Next is, again, another implementation defined thing, a tag. This could be really anything. You could have the name of the sending service here if you want, or maybe a name of a site you have. It's just pick any string, or don't. Well, you would have to include something here, but you could just have a constant string if you're not actually using this. And finally, the domain of the Eiffel event. We haven't talked a lot about domains so far. Mattias is going to talk about it quite extensively in a few minutes, I think. But it's basically a way of segregating your Eiffel events into different domains. Could be based on access, could be based on sites. That's up to the organization how they choose to do it. But this would allow you to route messages depending on those domains. So a couple of actual examples of how we look for producer and a consumer. So the top example is what you would actually send in a routing key as a producer, assuming you don't have a tag, you don't have a domain, you don't have a family. You could just use an underscore or any other character you like. It doesn't really matter. This is what at least a few tools do. And secondly, the consumer, that's the example of the binding key you would use when you set up your queue for consumption. In this case, you would use a star in place of the family because you don't care about the family. Maybe you don't use families. And at the end, you would have a pound sign to indicate that you don't care about the tag or the domain or the number of dots that you might have in the domain. It's just like give me all the artifact published events. I don't care about the rest. So in terms of compatibility for this standard, I think we standardized on it 3 years ago. And the Go SDK supports it. So does the .NET SDK. Eiffel Python lib does as well. That's sort of the Python SDK as close as it gets. Eiffel Rembrandt published gained this ability, I think, about a year ago in 2. something. The Eiffel Broadcaster plugin for Jenkins supports it since this spring, I think. And finally, the Garrett plugin. Well, I should say the Events Garrett plugin supports it. The other, Eiffel Garrett plugin, the older Garrett plugin does not support it. It's basically unmaintained. So fairly wide support. And back to you. Unless there are any questions on the routing key, of course. Sir.
Just one question. Before when you had the consumer.
Once again. Don't want to miss away from the microphone.
Yeah, that works a lot. Oh, but, in the routing key that you have in the Eiffel standard for the consumer, why did you use the pound sign instead of a wildcard at the end there?
Oh, see if you can just back up, yeah. Well, I could have said star to star instead. That would have been totally fine and basically equivalent, unless, of course, you have domains with dots in them.
Okay.
Because then, yeah, so you can have, if the end of the routing key would be random tag dot domain 1 dot domain 2, for example, technically that would be valid. But if you use star dot star in your routing, your binding key, then you wouldn't get a match.
So that would mean that the wildcard star is only compatible when you have dots in between them. It's between the segments.
Exactly. It's only between segments.
And it's not like a standard regex wildcard where you have a standard where you have everything between, so to say, including dots. But okay, that makes sense.
Yeah. So stars are between segments, and pound signs they don't care about segments. Boundaries, just anything.
Yeah, thank you.
Anything else? For anyone?
Do you know if there's any performance differences if you use a star for the family or if you actually have the family of the artifact publishment, for example, that's the artifact?
I don't know for sure. I think it's probably yes. If you would profile, there would be a slight difference. But I mean, you would have to publish a lot of messages for it to have any significant difference. I mean, I'm pretty sure they're not translating these to like regular expressions and applying them on everything. They're a bit smarter than that, I think. So I wouldn't worry about it.
Okay.
Was it?
One question. Maybe I missed something. But before Mattias just stated that it's better to have 10. Was it consumers then with 1,000 messages, or was it then 1,000 messages then? Something like that. Have I mean? Yeah.
So it's kind of like general that if you have a lot of queues, especially if you're talking about old RabbitMQ queues with the classical queues, if you have a lot of queues, those queues will take up some memory and so on. So if you have a lot of queues, it will build up. So that's why it's more preferable to have a lot of messages in queue, or RabbitMQ is going to go better with a lot of messages in one queue than having a lot of queues because of overhead per queue, basically.
But these consumers are the ones that's defining the amount of queues. Or...
Yeah. So also in classical queues, you basically have one queue per consumer, but there are newer queues. I think they're called streams, where you can actually have many consumers on the same queue to improve performance. So if you're going to go into that and you check the new queues and how to use them, because they are different, they have made RabbitMQ much more efficient in newer versions.
But you can have multiple consumers on single queues, regardless of what the queue type.
But if you want to process all the messages in the older queues, I think that if you consume it, of course you
Okay. Depends on why you have different consumers. If you're doing it to scale horizontally, then it's one thing. But if every consumer wants to process every message, then yes, they need separate queues. Okay.
So let's talk about scaling. We can talk about two different types of scales, infrastructure scaling and something I call scaling through partitioning, which we're using in Ericsson. This is where domain comes in. But if you start with infrastructure scaling, so RabbitMQ can scale both vertically and horizontally. Vertically is you add in more RAM and CPU and so on. But you can also scale out and actually add in more nodes. So that's one way to scale. There are other ways. There's something called constant hash change that people talk about using. I haven't used myself. I'm not 100% sure that it works well in this scenario, but it's basically that you hash the routing key, and then based on that hash, provide it to several exchanges to process it, and then you can process much more messages. So it's good to be aware of that those tricks or tips and tricks are there out there if you need to scale. But if we go into this partitioning now, so here we have the consequent domain, and in Ericsson we have a broker, and rather than queue, we have an event repository where you store all the messages from that domain. We also usually have some workers, changes that people want. Then we also got several local domains. And in order to communicate between these domains, we have a global broker that then federates between domains. So if you want to get a message from another domain, then you have to federate by the global broker. In Ericsson, we federate the artifacts, basically like the components published and the constantly modified. Created, publishing by default, so all domains will know about this. So the reason we have the domains is we want to be able to group components. With this, we can actually then upgrade each component individually. So we take down event repository, we can take down the rapid queue and so on, and upgrade it without affecting the other domains. These domains then can span us for sites. And we try to map them to common sense needs, like if you got some people working with, I call it a product, what that is, but some kind of group of people, and you would then send basically all events in that domain connected to that product. And with this, you actually have a domain, then you have some kind of decision power. So a domain can then decide whom to share events with. So if you would have a domain for pure like tested up, you could maybe decide I don't understand this out to other ones. And you can also check who will access the events, because these are separate components. Then you can do access control for each component. This is then enabled by the called Rapid Queue Federation plugin, and it's there then to basically track the message between brokers. These can then be in different data centers. You can have on different continents. You can have completed setups. In one, it's one user, another one is another user. Different permissions, purposes. They can be running completely different versions of Airline and so on. And they can be completely different sizes. One might be on a laptop, one might be in an iPhone as well. So it's really decoupled if you're using this federation. Just as a note, there are two types: Exchange Federation and Queue Federation. I won't dig into that now, but you should be aware that there are. We're basically using the Exchange Federation within Ericsson. So, if we got any questions?
Christy's laughing here because he knows so much about those questions. Now, how much could you scale it? Could you technically have federations of federations upwards? So we have one federation broker for, let's say, 4 domains. Could you then for say Sweden? And let's say you have one federation for, let's say, US. Could you then have a federation of federations that basically act as a federation for, what federations are for downwards? Could you scale it even more so? If you say, let's say you have instead of a global broker, you have a Sweden broker and a US broker. Could you then have a global broker on top of that to scale it even further?
Yeah, so this is actually a simplified picture of what we have. I don't want to bring it now, but the global broker is the whole thing, and then we have domains, and under these domains we have sites. So there is something actually like that, because when they set it up, it was here. And Bo here was, who knows a lot more about this, wants to say something.
No, I just want to comment on the fact that what Mattias said is true. We don't have sort of a multi-level domain structure. But there's nothing hindering you from doing that. It all depends on how you build up your domain name and how that is a structure. So theoretically, yes, it could be done. And if you implement that with RabbitMQ to sort of how those federations being done on a multiple level, you can build quite complex Eiffel domain structures if you would like to do that. But it's not been done that way at some point.
I just think that depending on how you scale it, the global broker can become a single point of failure. If that fails, the federation fails. If that fails, the software development fails because the components between the different domains that need each other, let's say the artifacts need each other in different domains. If the global broker fails, then the software will stop being produced. So I'm thinking as well, only more abstract, higher abstraction layer, but yes.
Yeah, in one case, yeah, you do that. Of course, you could make some kind of high available RabbitMQ, for example, if you have several clusters. And I think I'm not too into that one, but I think you solve it. But also be aware of when you have this broker set up, if the global message bus is down, the sub domains will save the messages in the queues. They won't send it until the one is consumed.
Yeah, just to give additional comment, so it is true that in this particular case, the global broker in this picture is sort of a single failure, if you will, a single component failure. But it can be enhanced by using RabbitMQ clustering, which is the free stuff available. You can also sort of evolve the design. You can have multiple parallel brokers that needs to be known, but each the sort of subdomain, so you can have alternate ways. So you can do sort of a structure of routing that will be similar to what you have in sort of internet routing you will use, and sort of one way that is possible. But that's basically decided to put into the RabbitMQ and that configuration. So there are possibilities to increase the resilience of that by designing it differently. But once again, these are the limitations shown at the current alternate configuration. Thank you.
Thank you very much. Maybe a stupid question, but does RabbitMQ or is there a tool for RabbitMQ for detecting cycles? If you accidentally put one of the lower federated under the global one, create the cycle that way, or configure queues to pass on to those two queues, and then yeah, you get the point, I guess.
Yeah, Bo is pointing thumbs up, so yes, I guess there is tools for that.
So it's done. Okay, cool.
So what happens if one of the queue gets corrupted and you have messages? Are they going to be lost, or because you have this global broker, or because in the previous slide you also mentioned about scaling? So is there when one of the queue gets corrupted, like where are the messages going to be saved? Because we had kind of similar issues we encountered a couple of months ago.
So you're talking about messages in the queue, because RabbitMQ does something, it corrupts the queues itself.
Exactly.
So I know that you can save it to the disk, but that is basically when something goes down. I'm not 100% sure how it works if you get corruption within the queue, but that seems like a bug inside RabbitMQ. And I haven't heard anything about that, but I'm not into those data maintenance. Oh, you might want to say so.
Well, absolutely right. There's a bug, of course, that tends to have, in this particular case, the nasty thing of corrupting the data. That means that the entire database, the Mesa database that this is built on, is going to be corrupted. So even if it's taken to disk, it will basically not be solvable. So the only way to do that is to make sure you have frequent backups and actually upgrade to the right version to read the rough copies vulnerability.
Any other questions?
One question about the federation here. Are the federations sort of smart in that does the federated domain know if any queue will even consume the messages, or is it just like fire and forget what federates these events?
Who do you want to answer it directly?
Well, I can try, but this is not my sort of area of expertise, though, but there are some, let's say, smartness included. So you do not really sort of forward information through federations unless there is sort of a queue that has some sort of need for that. So there will be sort of an optimization of information passed between different federations based on whether you have a queue with a particular interest on those topics. Exactly how that works, I'm not sure into that, but I know that is the case. Thank you.
Thank you.
I guess it uses the binding keys to verify that the message is relevant for that queue. So federation uses the binding keys from the consumer, or from the in the queues. So.
Yeah, I'm looking into the segmentation or isolation of event repositories. Would that be a problem if federated events come to each domain and you would like to search upstream data, and we don't really know which repository to look into.
You're a bit ahead of my slides. So I will postpone that question.
So a question of if you have, since you at Ericsson have been using Eiffel for the longest, what is it that drives you to start segregating it into domains? Is it performance-wise, or is it just said something about access, or is it just somebody thought this was a cool thing to do, or are there any tips and tricks for people that are just might be getting to the point where it seems like they're stumbling into issues with just having like one domain?
You're also ahead of my slides.
Okay.
Postpone that question.
The one best, because Matthias has prepared everything. I think you go on.
Yeah, so coming into reflection on the Ericsson setup. What do we have today and how do we get here? Starting with this, I just want to start on the positive side as an engineer and always look for problems. We have something today that works well, send out 4 million events per day. And basically, if this goes down, we wouldn't produce anything. We are heavily dependent on it. So it works today. That's all. Okay. The question is here is a little bit, would we do it differently if we start off today? And probably, we would probably do it a bit differently. So that's the kind of reflections that I have here. Originally, we had 3 different domains. Today, we have over 100 domains, which is that we have over 100 message brokers.
It's a number.
200. Okay. Right. 200. Oops. So how do we get there? When you're setting up something like this here, you need to learn that you need to have some kind of governance. As I said yesterday, if you're working with engineers, they will find ways to get it working. So that is one thing. Somebody, if you're going to set up segregation something here, make sure you have a governance to drive at least the rough direction. And when we started, we had a problem with the upgrades. We did not have like 0 downtime in the components we're using. So therefore, we split it up into domains so that each of the components could upgrade themselves. Or each user in each domain can upgrade them. We also have, because we're running on older routing queues, and we had some problems with consumers not consuming messages who are building up, and therefore we run into issues. We were using the old queues, and we had this fan out problem. So the idea here is you get one message in, and then you have a fan out because you have several listeners, and each listener must consume all events, and then you build one queue for each consumer. So if you, for example, have 2,000 consumers, you get 2,000 queues. And if they stop consuming, then of course you'll build up, and then queue is not going to be that happy. Now, I should point out to this, as I said before, your versions have other solutions for this, so please check that. That's one of the things that we run into that we need to be split apart for. So some reflections about domains, the good and tricky. Definitely having some kind of logical grouping is something I would heavily recommend. It could be, for example, if you've got a staging or production environment, then you can easily filter out, okay, these are all staging and I don't want them. So that's good, and also for understanding and reasoning. So logical grouping, yes. But with domains, you usually got like physical partitioning. And there are some tricky things in this. Yeah, this one. If you've got a chain, for example, artifacts created, published defined, which they submitted, and you got them in 3 different domains. Then you got the trickiness of if you want to find the source change from the artifact, then you need to search through several databases. So that is the problem. Then we get to be aware of this. If you want to split, then you split and come back to your rocket money. If you need to split database. Also, for Sunder, if somebody's coming in about 3 domains, if it's not really clear where to send the domain, then the Sunder will be confused and more capable where they want to send it. So that's also something to be clear what each domain is actually going to be used for. Listening for some domains, for example, if you need, like my previous example, need it, then you have to make something to work. In some cases, we have created a listening domain, which is a tool that needs all the information and basically listening for events from all the different domains. We also have some event repositories that also pump in the events from all the different domains. Also, since we have many different domains and brokers, the upgrade responsibilities then on the domain owner user. So when to upgrade is on them, which is like you might have a very fragmented landscape of versions. Also, if you have a lot of different infrastructure components, there will be problems of time cost. That might not be heavy. But even if you use like Kubernetes, you probably will have some biggest load just setting up new database. So that's good to think of. There are good sized rigs, and primary one I could think of was secure zones, but there are probably other use cases when you really want to separate it. But when we talk about security, be aware that newer versions, Redmake 3.9, you can actually have read and write access on topics. So be aware of that. The bottom line of this one here is don't just create domain-based organization charts, because in my life we reviewed Ericsson a couple times. So those are probably great, but if you've got those special use cases, then do that. Maybe it's better to organize around products instead of a stable problem of your organized slightly. But when we're talking about security and separation, some cases you think, well, this probably is some reason for creating a domain, an answer to that. So if you're talking about event content tampering, I would say start thinking of like zero trust. And as Magnus talked about yesterday about assignment events, that's probably a good way to make sure that the event who's sending it is the events, rather than relying on message bus authentication. So one thing also, if you're signing an event, you can actually check it afterwards while it's in the database. If you got sensitive information on this event, you might think, well, we need a separate domain or something. The recommendation is not to have sensitive information on that system, but it's a link to it. And then let that, what you link to do the application on the user read. Yeah, but then if you got information which you definitely want to send it, yeah, maybe there's a reason for it for domains. It could be other reasons for it, but this is the main idea that I thought. So in the talk, I said talk about databases, so I'll rehash what I said. Separate database, yeah, read access to problem motivated. But then also remember if you're splitting it out, that if you're going to read and so on things, then you probably need to make workarounds. Also be aware of cost. Setting up some of the databases will have some kind of cost, even if you're working with something. If you're thinking about, well, we're going to have some serious read problem with that, that's when we want to split databases. There are other ways of doing that. Something got out one node for finding two and multiple others to read from. So you can have just one system. So some takeaways. Yeah, as I said before, have a foundation to set like the core ideas you want to have. Some group responsible for it, maybe not because of the group, but virtual group, something. Within platform. Diverging, yeah, you will leverage probably if you let everyone do it on their own. When you're setting up something, do think of the user use it, put that person first and go into their shoes and think, okay, how is going to be using this setup? How do we make it easy for them? Repeating again, make sure you get the right use of their ass, things there. And also really get the data on how much you need. So when you go into solution, make sure that you're not picking something on a hunch, but really how much data are you actually need. And also seamless upgrades experience we had because we split it apart because it's, so this is something that probably now is not that much pushing, but you think of it. So now the questions. I postponed 2 questions, sorry.
No.
Did I answer your question now?
Can I just comment a bit on that actually? If you go back to that slide showing different domains with event repository, some slides back. And I will refer to Tobias' talk this morning as well. Yeah. So in this case, we have 3 different domains where these different events are sent and they are interlinked. If you would then listen for this artifact created event, maybe through the collector, then the collector would naturally go to that all domains ER and should look at that event and try to do an upstream search based on that to find the other ones, but it won't automatically do it. There was one property in the example that Tobias showed that was called shallow. And if you set shallow to true in that call, it will not look for any other errors. If you set it to false, it's not shallow anymore, then it could be deep, so it will be a deep search. But in our solution, as far as I'm aware, we can only actually find events 1 step backwards to one other ER. I don't think we can find it 2 steps backwards. We can actually not find the SCS event actually in our current ER solution, I think, if I'm not mistaken. So that's something to keep in mind. Anyway.
Yeah, did I answer you? Did you have any more questions? Follow up on? Did I answer your question? Good.
I have one more reflection. You also mentioned one reason for having multiple domains is that you can have one staging domain, one domain made for staging purposes. And in our case, as far as I'm aware, we don't federate the events in the staging domain to the global broker, by default at least. Obviously, because some markets that like test events, those are sent there.
Just note as well that when you have users of different domains, this is from when I was in Ericsson as well, make sure to actually communicate the standards, because we battery or two. Okay, well. Because I remember when I was in Ericsson, we did not follow the standard Eiffel routing key message, and eventually when it eventually was implemented that you have to use it, our messages stopped working. So make sure that when you create this core group, the set of standards, make sure you have the communication infrastructure to also send it out to the users so they know exactly how to do it. Or else engineers will engineer and do what they want and try their own things, which will eventually break. Just a note of that.
Exactly, that was one reason for creating the RemRem service actually. Because when people used RemRem to send events, RemRem would automatically create a valid routing key on the message. Not the perfect solution, but it's one step in the right direction.
Sorry, routing back to Johan's question. I didn't follow along to the other where you had 3 domains. Next image, I guess. What was the answer about how do we know in which record to find for a specific one? Was it just rhetorical questions there, or was there a recommendation on where do you look for which dimensions? Yeah, how do you answer that? I didn't follow.
No, I don't got a good answer to that one actually. I would say that would be it's something to think of, but maybe an answer would be if you just have domain 1, 2, 3. Then you won't have it, but if you have some kind of more logical setup or understandable thing, people probably, okay, I'm supposed to send it here. Or if you have good standards for documentation, where should I go and send my events? I think that would be kind of like an answer to it.
Okay, so there should be like governance all over again. Like, okay, in domain 1, 2, 3, we have the separations.
Yeah, if you're going into this domain-wise, maybe you could just run one domain.
Yeah.
And I mean, the routing keys are very powerful, so you could probably sort through those routing keys and not having separate domains.
Okay, so I guess you said it in the beginning that if you would do this all over again, you wouldn't go this path. So you would choose another path instead of domains.
At least not ending up in 200 domains, because that is tricky. Because as I said, with listening, we've had some reports when we need to listen to many domains and then have to engineer around that. So it would be easier if you just have one domain there.
And finally, as for my own understanding here, is there a recommendation? I see this solution. Okay, this is not the best, of course. Then, as I said, how should one do it instead? Use routing keys in one domain, or was it another recommendation?
As domains here, that's a physical separation. But absolute logical separations you can have several of. So there isn't a limit like in the logical one, but if you would start with a physical setup, I would say start with one and see how much you can get there. And if you run into problems, then maybe you will in here. But going default to this one, I wouldn't recommend. And then this could be a backup, but start with one domain, I would say.
Just to comment on maybe you should or should not, there's no written recommendations on how you should apply domains and what sort of setup is best for your particular company. But one thing that could be sort of put into mind is to see whether you have multiple entities, for example, in the same company that will use Eiffel. And for that, you may want to sort of segregate them because they may be sort of connected or stay disconnected for a while. But in such cases, you do have sort of autonomy perspective on it. So each group can define how they will do in terms of the versions, language components, and so forth. So that may sort of ease the use of the different components or systems that relates to the Eiffel domain. Another thing to mention here also is the life cycle of an Eiffel domain. It all depends on the product you develop or the entity that is supposed to use Eiffel and to what extent it will live for 2 years, 5 years, or 20 years. So if you have a reasonably good setup, you can also sort of close down certain entities and the domain without impacting all the others. So it depends on your life cycle management. Domains can also be used to sort of clean the start and shut down certain entities without impacting all the others as well. So there are multiple factors to think about here. Thank you.
Just gonna comment on that as well, to go a bit of Volvo language in that sense. For example, we could do it like we do with the Jenkinses, that you separate them on the area that of the teams that are working with the actual CFD. So for example, powertrain, VT, is a BCE, so on and so forth. That could be a logical way to go, because then you can have the governance, the domains managing their own as well, and their own, and decide what events to send. That could be a logical version. Just want to give an example of it.
I assume they might reuse components between those areas as well, maybe, and then we want to see the events from the different components, maybe.
Yeah. But I think you said it, that organizations tend to change.
Depends on which level of safety.
Yeah, sure.
That just change like you described that. But if you go on higher level, it will be for example, cats. That's something happening there. But it's not main cat, but it's still the same type of thing. This, for example.
Magnus.
Yeah. I thought things came in a different order, but they don't. Okay, that's fine. So we're going to look at a few patterns I've been thinking about when implementing services that consume events. So first of all, it's a really simple principle, really, but use an internal queue for the events that you actually want to process. It depends, of course. You know, sometimes you want to process every single event that lands in your RabbitMQ queue. That's not always the case. For example, if you're processing source change events, maybe you only want to react to events in certain repositories. The rest of the events will just, pass you by. So you would have a first point of decision when you get the event. If you decide that, yes, this actually is an interesting event, for example, is for a repository I care about, put it in an internal in-memory queue. It could be any linked list or, whatever data structure you want. And then you can process it using some kind of a background worker, a thread or whatever works in your language. One benefit of this is you can easily spin up multiple workers and parallelize the work. If the event is not interesting, you can immediately acknowledge it or enact it and just get it out of the way. Processing events in parallel is one reason for doing this. Another one is that if you have problems in your queue processing, typically you would have the processor will go into a refining. If you're accessing some external system that either is not responding at all or is responding very slowly. the queue would otherwise start backing up. That could be a problem for the broker, but it would also be a problem for you because it's harder to monitor a queue where sort of if you're monitoring the queue on the RabbitMQ side, and it could be growing quite a lot with irrelevant events that you're not going to process anyway. But if you're able to immediately acknowledge or enact them and only have in your internal queue the ones you really want to process, you can measure the queue length and actually get a good measure of what the actual queue is. If you do that, an important thing is make sure you're setting the prefetch count for your queue or for your consumer to an appropriate amount. The prefetch specifies how many events, how many outstanding events you're allowed to have in your consumer. In other words, how many messages is RabbitMQ going to push to your consumer before it starts to get acknowledgements. So with your internal queue here, if you have a prefetch of 10, for example, you will only get 10 items in that internal queue. Then RabbitMQ will stop sending you things. So make sure you match the internal queue size and the prefetch count. Don't choose a too enormous prefetch count. Maybe 10,000 would be reasonable, probably not hundreds of thousands. I've seen cases where that's an important thing if you don't know. The reason this is safe is because outstanding messages will be requeued if you're disconnected. So you don't have to persist the internal queue. It can be in memory, that's fine. RabbitMQ will take care of requeuing those messages if you are ever disconnected in an uncontrolled manner and have messages still outstanding. So that's fine. But I have seen cases where bugs in applications where they're not acknowledged messages. So they rack up hundreds of thousands of unacknowledged messages in the queue and they disconnect. And at least older version of RabbitMQ had to make a memory allocation to fit all those messages. And maybe they didn't have memory for that, and then the RabbitMQ would crash. So again, don't choose enormous prefetch values, but several thousands, tens of thousands is probably just fine. Entirely different problem then, because it actually goes into sort of how would you implement your own Eiffel collector, or someone who would, a service that would look at series of events and decide to act on something. For example, in this case, let's say you want to trigger something when an artifact becomes available. So the trigger in this case is the artifact published. That's where you get the URIs for the artifacts, and you can actually start doing something. But that event in itself doesn't tell you enough information. You only get the URIs. That's probably not useful for you to decide what to do about it, unless you start parsing URIs, which you shouldn't be doing. So at the very least, you have to see what artifact are we publishing here. And that artifact could also, it will probably be connected to activities. And it could be that your conditions for the triggering conditions should be dependent on what activity produced the artifact, and so on. So somehow you have to keep all of these events to their complete state before you decide what to do, which is pretty much what Eiffel Collector and Eiffel Intelligence does. But if you don't want to use those, if you want to implement something yourself, a few notes on how you do that. A not great method of doing this would be to, for each event, look up all the necessary events, follow the links, and ask the ER. That's going to result in quite a lot of queries. It's going to be slower, it's going to put load on the event repository, and it's going to be very dependent on the event repository to respond in a timely fashion. Otherwise, you're going to have problems. But it's simple, but it's a bit naive, and it'll probably get you into trouble. So what I suggest is it's very similar if you've been working with streaming frameworks like Apache Flink or Apache Spark or similar. This is really just sort of the same thing. So when you get an event, inspect it and see, could this potentially be interesting? Does it, yeah, it is something that you keep around for later. So this could be the artifact published, for example. No, sorry, no, that comes at the end. No, sorry. So this could be an activity, for example, activity trigger. Based on the activity name or some other property of that activity, could I potentially be interested in this down the line? If so, you create a bucket for it. In other words, some kind of set of events stored in an internal database of some form. If it's not interesting, does it link to something that's interesting? For example, if you get an activity started, that might not be interesting in itself, but it could be connected to an activity triggered that you previously created a bucket for. So if it links to an interesting activity triggered, store it in the bucket. And is it a trigger in itself? For example, if it's published artifacts you want to trigger on. So the artifact published would definitely be stored in the bucket because it links to something you've already deemed interesting. The artifact creation, because the artifact creation links to the activity you're interested in. So you store it in the bucket and then look, is this a trigger for me? It's an artifact publication of an already interesting event. Good. Then process the whole content of the bucket, and then you can remove the bucket. That's pretty much what we do with a passive link, but it's simple enough to implement yourself as well. Any questions on these parts here? Yes, go for Emil. Whoever gets to go first. Emil is polite.
Just sort of a comment on sort of the general principles on how to use subscaling in connection to mapping something from a message broker, for example. If you want to do things, so if you want to read or work on any messages that come from message broker, I think it's somewhat interesting to know where we can scale things in a stateful or stateless manner. Usually when you're sort of consuming something from a message broker, and if you're stateless, you can probably scale that very easily and infinitely. You don't have to care about it, as long as you are really keen to sort of make sure that you always take your acknowledgement and the quality of acting upon each and every event. But if you start to introduce statefulness into your service, those instantly becomes much trickier to scale. So it gets sort of a scaling problem. By one of the ways to solve the problem that is scaling this in the first place. So just a piece of advice would be to be very careful on which part of the service is stateful and which one is not, in order to ensure you get the right scaling into it.
Yes.
That's it.
Yeah, that's a good point.
Yeah, okay, great. That was it. I would say this solution that we see on the screen is very similar to what Eiffel Intelligence does, and not what the collector really does then, because Eiffel Intelligence actually does store interesting events that exist in their rule engine. These events I want to store for later, because there might be a subscription. We don't call it triggered, but there is a subscription for this whole bunch of events. That's in Eiffel Intelligence. And regarding the state there, in Eiffel Intelligence, the state is externalized to a database and not stored within the memory in the service in Eiffel Intelligence. But that also comes with a cost, because then you need to, when you see another element coming in that is linking to the previous one, you need to fetch the whole structure from the database and add this new event on top of it and store it back, which is also a performance issue there. And one maybe major problem with this that makes it very hard for us to use in Ericsson is our use of low context defined events. Because the interesting event there maybe already came 2 years ago before this service was deployed. So our way of using low context defined events is we categorize all events for our products, for our different project lines, and the project might live for years. And then the flow context event had been sent like 2 years ago when the project was started. And all events coming after was just related to that event. So that's why actually variance has in its beginning there an ER search to find older events as well before this interesting event happened. And one more reflection then on the need for these lookups towards ER is that if we would cache the calls to ER, for example, on these flow context events again, that means we wouldn't need to ask ER every time, because the same flow context ID will be asked for multiple times, so we can cache it instead. That's another way to solve not needing to request data from the ER.
Yeah, if you're, as long as you're not making queries for, I mean, yeah, if you're asking for a specific event, that's super cacheable. Queries are not, unfortunately. Yeah, any other comments? No. Oh, yeah.
I just wanted to sort of acknowledge what you just referred to. Do use the property of immutability. It was a bit discussed earlier that, oh yes, we do not change the events, and so of course, don't be worried, we should never ever change the events. Events are immutable by nature and should be kept as the most sort of secret or sacred sort of key you have. Don't ever change, because if you do that, and if you're working with immutable events, you can basically copy them endlessly, and it will never sort of go out of date. So in order to sort of make it easier to search and to find event that's being pulled out of any message broker whatsoever, for example, in an ER, whatever, do copy them, cache them as much as you can to make sure that you have the better. Use as many technologies you can do the searches, do even selective storage or caching, just because of your particular use case. So make them sort of endless copying capabilities that comes with immutability to your advantage when you're making your implementation, because that speeds up things without losing anything. Thank you.
Yeah, that's good advice. I'll continue with sort of our equivalent of Mattias' description of Ericsson's deployment. But this is going to be a lot quicker. It's just this slide actually. So we have actually sent almost as many events. I think we're at 2 or 3 million per day with just one domain. So it's very different. So this is what we have deployed in terms of Eiffel infrastructure. Not that many components. Again, we just have one domain, so it's not being replicated in any way. So we do use Eiffel run publish for publishing events. We don't use it in too many places, but a few of them. Mostly Ethos, the test orchestrator, is responsible for the vast majority of the 20 events per second that we send in this way. I should say all the numbers here are averaged over a week. So total number for a week divided by the number of seconds in a week. So peak load is going to be significantly higher in all cases. We also have a number of other publishers who publish directly to RabbitMQ, slightly less from them. I don't know how many such we have. 5 or 10 maybe, not that much. We run one RabbitMQ cluster with 3 nodes. Nothing spectacular hardware-wise. We don't use it exclusively for Eiffel. We use it for various other things as well. We used RabbitMQ in this manner before we started with Eiffel, so it was very easy to get started with Eiffel. It didn't really require any new infrastructure such. In terms of consumption, we have 3 consumers, 3 types of consumers that we count within the infrastructure field. We do store everything in Elasticsearch, which I think you did involve as well. This isn't meant for any kind of persistent storage, just for convenience, being able to access it from Kibana. Maybe you want to just search for events in a convenient way, or you want to look at how many, it could be anything, how many source change events are we actually sending, where do we have peaks in the house, general health of the system, or there's so many uses. It's so simple to access it. Again, we had that, we used Elasticsearch and that stack for other things already, so it was super simple to set up. Maybe not, if you don't have that infrastructure in place, maybe not worth it to set it up just for this, but it's still quite convenient. We also have a backup service, we call it, which simply just stores all the events received to the disk that IT manages and backups and all that. The reason for that is mainly because of disaster recovery for the otherwise main MongoDB database. We don't have continuous backups of that data. So if there is a catastrophic failure, it doesn't really matter if we have backup, 1 hour old, we're gonna, during that hour, we're losing hundreds of thousands of messages perhaps. And with the nature of the Eiffel graphs, just losing one event will break the graph and you're in a bad place. So the backup service is there just to make sure really that there is almost zero chance of us ever losing anything. And there are some side benefits as well. If we would want to just get past events in bulk for whatever reason, want to try a new type of database. We've seen cases where researchers want to get our events for research purposes. We can easily get a week's worth of events, super easy, without extracting it from the database. So it's very, very simple and can be quite helpful. And if you compress events, they don't use a lot of space. I think we're using, 100 gigs maybe for many, many billions of events. So it's simple and cheap. We have a custom service for inserting into MongoDB. It currently isn't open source, but could very well be. It's quite well performing. Originally, we used one sort of side component of the Eiffel GraphQL API, which perhaps surprisingly had a way of inserting things into MongoDB, but it wasn't very efficient. It didn't insert anything in bulk, so everything was fine until you reached maybe 20 events per second, and then it would start to fall behind. So we had to write the MongoDB inserter on fairly short notice. Yes, we do use MongoDB with a different schema than Ericsson uses. I think you have everything in one collection, I believe. We have one collection per event type. So they're not entirely, they're not at all compatible actually. And we have two APIs for accessing the data in the event repository. We have the Eiffel GraphQL API, which a few folks at Access maintains. And it's a GraphQL API towards accessing the events. One of the benefits of it is that you can, you don't ask just one at a time. You can get multiple deep and select what kind of links you want to follow and so on, which you could do with the other API as well. But anyway, and we also have Eiffel Goer, which is an implementation of the same API at Ericsson's event repository, which is not open source. It's open binary, you could say. So we have defined, I think we finally set that specification as though, for the time being at least, this spring, the API for the event repository, which is based on what Ericsson's event repository implements, but we've scaled it down a little bit and removed the things that we didn't feel were strictly necessary. There was a number of special features that we don't think we should force every implementation to actually implement. So Go implements almost all of that. And I think Ethos uses it a little bit as well. Yeah. And then some other internal services we have. So that's it. Any questions on this?
It's the interesting concept with the backup service. Can you share any bit more details? How take an event and store it on disk? Is it 1-to-1 file?
No, it uses it. I mean, it's super simple. It's just serializes the events as JSON, one event per line. And I think we rotate those files every hour, and upon rotation, we just reset them. So it's that simple. The only not entirely trivial thing is that we batch the writes. We don't write every single event. We batch, so we make like one write to the file every second or something. So it's quite performant. We're doing the same thing with the MongoDB inserter, by the way. So we batch, since we have multiple collections, we have to have one batch per event type, and we flush after either 1 second or we reached a few thousand events or something. So it's also quite performant. I think we get an insertion rate of 600 per second or something. So there are cases where we lag behind a little bit, but it's pretty okay. The backup service can do thousands of events per second, no problem.
More questions? Comments? Reflections?
Yeah, I believe, yeah. That's it. If there's nothing else, then yes, sir.
Just curious about the retention policy of those backups. How long do you keep them?
Forever.
Forever?
Yes.
Oh, interesting. So would you just scale up the disk when it reaches more, or?
Yeah. So again, we have, I think, less than 100 gigs, and that's for all the time we'll be using Eiffel, for like 5 or 6 years. So it's not that bad. I mean, they are very compressible.
Yeah.
We don't have any retention policy for the MongoDB database either. So if you want to know what happened with a particular test case run in 2019, you can have that information, which is a bit of a problem because that storage is more expensive. So that's something we should probably talk about at, I don't know, maybe at the Q&A this afternoon, how to actually remove data that's no longer interesting and how to do that efficiently.
I'm thinking possibly not rather removing, but placing in storage that is less frequent. Those are cheaper.
Yeah, I mean, yeah.
Or infrequently. More cost per transaction, but less per store or something.
Yeah. I don't know if there's any possibility of using like cold storage tiers for MongoDB. I don't know. But, well, I mean, we have the backup service storage. We already have the cold storage if we need it. But I think what we probably should implement is removing, for example, old test case events that are just super old. Maybe not remove them just unconditionally, but test case events for like non-releases. I mean, test case result that nobody could possibly care about. We don't have to keep them around forever. But for customer releases, yeah, there could be, and there's a few that if we want to save them for 100 years, it's not going to break the bank.
I think as it depends also, I suppose, on the legal restrictions there as well. If you need to keep test cases like for 15 years for legal reasons, that is very possible. But very cool. Thank you.
So if you start signing events, the size will grow.
Yes.
To store those.
Yes.
As well.
Yep.
I guess the hash will not be as easy to compress maybe as other free text parts of the event, so it might be harder to compress it.
Yep. That's probably true, yes. Thank you.